Good morning, dear students. I hope that you all are doing well. From today onwards, we will revise the topics for our upcoming online test. But kindly go through your notes, assignments, and textbooks to prepare well. Avoid last minute or moment revision or practice. So, in chemistry, we studied lesson 1 and 2, which are the portion for your online test. Lesson 1 is matter in our surroundings. Everything in this universe is made up of material called matter. The properties of matter include the substances which occupy space and has mass. Each matter is a collection of lots of tiny particles, and particles of the matter are continuously moving. On the basis of the characteristics of the particle, we do observe physical nature of matter, such as the particles of matter are very tiny, the particles of matter have space between them, the particles of matter are continuously moving, and the particles of matter attract each other. This can be seen with the help of following activity. Like for example, dissolve 2 to 3 crystals of potassium permanganate in 100 ml of water in a beaker. Then take 10 ml of this solution and dissolve in 100 ml of water further. Take 10 ml of this solution and dissolve in 100 ml of water. Repeat this process 5 to 6 times. This shows that a few crystals of potassium permanganate can color a large volume of water because these are millions of tiny particles containing in each crystal. This shows particles of matter are very tiny. Let us take some water in beaker and note its level. Dissolve some salt or sugar in it with the help of a glass rod. The salt or sugar dissolves in water, but the level of water does not change. This is because the particles of salt or sugar get into the space between the particles of water. This proves that the particles of matter have space between them. Activity 3. Take some water in a beaker, put a drop of blue or red ink slowly along the sides of the beaker, leave it undisturbed for a few hours. The ink spreads evenly throughout the water due to the movement of particles of both water and ink. This shows that particles of matter are continuously moving. The intermixing of two or more different types of matter and its particle on their own is diffusion, which is least in solids and maximum in gases, whereas the haphazard or zigzag movement of particles is known as Brownian motion. Activity 4. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. It is more easier to break the chalk, less easier to break the rubber band, and difficult to break the iron nail. This is because the particles in the iron nail are held together with a greater force than in rubber band or chalk. This shows that particles of matter attract each other. On the basis of the particle, the force of attraction between the particles, and the movement of the particles, we do have three states of matter: solid, liquid, gas. Properties of solids. Solids have definite shapes and fixed volume. The space between the particles is minimum. The force of attraction between the particles is maximum. The movement of the particles is minimum. These are least compressible and their rate of diffusion is also least. Properties of liquids. Liquids have no definite shape but have fixed volume. Liquids take up the shape of the container. The space between the particles is intermediate. The force of attraction between the particles is intermediate. The movement of the particles is intermediate, these are less compressible. The rate of diffusion is more than that of the solids. Properties of gases. Gases have no definite shape or fixed volume. Gases occupy the whole space of the container. The space between the particles is maximum. The force of attraction between the particles is minimum. The movement of the particles is maximum. These are most compressible. Their rate of diffusion is more than solids as well as liquids. The states of matter are interconvertible. The states of matter can be changed by changing the temperature or pressure or both. This is known as interconversion of states of matter. This is the representation to show interconversion of states of matter and includes the changes. These changes or the processes help in interconversion of states of matter. When a solid is heated, it changes into liquid. When a liquid is heated, it changes into gas. When a gas is cooled, it changes to liquid. When a liquid is cooled, it changes into solid. These include melting, evaporation or vaporization, then condensation, and finally freezing. If ice is heated, it changes into water. If water is heated, it changes into steam. If steam is cooled, it changes into water. If water is cooled, it changes into ice. All the changes occur at specific temperature at a constant or normal atmospheric pressure. And we do include these as different points: boiling point, melting point, freezing point, etc. Of these, the change of state directly from solid to gas or from gas to solid is called sublimation and desublimation respectively. Like for example, if solid camphor or ammonium chloride is heated, it changes into vapor. If vapors are cooled, it changes into solid back. Another example could be of dry carbon dioxide, which is also known as dry ice or solid carbon dioxide. Effect of temperature on molecular motion. As heat is provided, the particles of the solid starts vibrating at its place. This vibration increases the kinetic energy, which results in change in state. Same as with the liquid. Effect of pressure on gases. When pressure is applied on gas, the particles come closer and the gas changes into liquid. We can liquefy gases by applying pressure and reducing the temperature. This is very commonly observed in LPG, CNG, oxygen, and nitrogen hydrogen gas cylinders. The LPG is used as cooking fuel, where compression of the gas, LPG gas, is by applying pressure and it converts into liquefied petroleum gas in cylinders. As soon as the pressure is reduced, the liquid gas converts into gaseous form. Compressed solid carbon dioxide is called dry ice. If the pressure is reduced, it changes directly to gas without coming into the liquid state. So, solid carbon dioxide is the example of sublimate, also known as dry ice.